Hello everyone. In this video, we will have a look at the deployment of charmed Ether SD core using Juju charms. And we will be following this documentation where we deploy charmed SD core in the cups model. The components will be deployed on multiple VMs on isolated clusters, for which we will use multipass to access. You can see the different network functions we have to add on the host machine. Moving further down, you can see different virtual machines that we have to create over here. Then moving further down, we have a user plane VM where we create interface to manage access and core. And similarly, in the control plane VM, we have to create management interface over here. Moving down, we have the GNB SIM VM and the Juju Controller VM where we define the management interface. Then we have RAN access and the core router VMs. Then moving down, we move to the SD core deployments where we use Metal LB as a load balancer for providing an external IP, and we have a user plane VM configurations over here for management for an access. So this is followed by the GNB simulator VM and the controller VM. Now we move to the SD core control plane. So now we move into the SD core control plane where we add models for control plane and create Terraform modules. It is here that we define the source model name and the things related to the control plane itself. Use the Terraform apply command over here, and you can see the watch command down here, just below that. So for SDCo's user plane, we follow the network configuration here, adding model for user plane, defining the source model name and UPF configurations, including the access gateway IP and access IP core interface, core interface IP, etc. And moving down again, you have the apply command and this command to watch. Then, as we know, we are using load balancer, use Melted LB load balancer, and then moving down over here, you can see the configurations we have to make in SD core in the main.tf file to define the application name and endpoints basically. So moving down, we see the Juju run traffic command. This is basically to show us the endpoints needed to access the NMS. Our NMS will include the following things like the name, MCC, MNC, etc. So along with that, we also have other things like MC, the key, the OPC, which are needed to create a network slice. So now we move on to the terminal. So here is the VM we have. Where we have defined all our interfaces. Like we can see different interfaces like access bridge, core bridge. You can move down and see the management bridge, the RAN bridge, and other interfaces over here. So now we will list all the virtual machine using the multipass list. And here we can see we have 7 different virtual machines. So now first we will go inside the Juju controller virtual machine, which is the main virtual machine for controlling all the Juju charms. So now from there, we have switched to control plane, and we can see the status of all the network functions in the control plane listed out over here. We have the units over here. We can see different list of network functions over here. We have the units of these network functions down there. And then further, we can see the relations which are defined over here. So after this, let us move inside the user plane. So in our case, currently, if we go inside the user plane, we can see that we have 2 UPF network functions, which are in the active state and they are healthy. Now let's go back into the control plane virtual machine to have a look at the pods available. So all the pods are running and we will now check the logs of AMF. We have not created any network slice as of yet. So you can see it is the status is not ready. Now we can look at the load balancing IPs provided to the AMF external and the traffic operator load balancer. So now we will go back into the user plane and see the pods available. And we have model operator along with 2 UPF pods in healthy state over here. So now let's see the logs of UPF 0. So these are basically the logs of UPF0. Similarly, we move on to the logs of UPF1. So now we can see that it is listening for new PFCP connections on this pod. And now let's look at the load balancing IPs for UPF. Well, after this, we will now move to create a network slice in the NMS dashboard, and we will come back to logs. So before that, let's move into the Juju Controller VM and run this command to access the NMS. So now we will run this command and use this link generated over here to access our NMS dashboard. So this is our NMS dashboard, and we will create a network slice. We can add information like name, MCC, MNC. We will also look at the bit rate. And for the second slice, we will edit the bit rate according to our use case. I will add subscribers to the respective network slices. And in the end, you will see 2 subscribers for our respective network slices. Now let's move back inside our control plane, and we can have a look at the logs of AMF. And this time we can see that we will have the network slicing information, where it will give us the information like GNB name, the slice name, the MC, the MCC, MNC, and the UPF information also. Similarly, we have the information for the second network slice with the edited bit rates and the same information as above. And this means that we have created the slices and the network functions are able to communicate with each other. We will now move into the user plane and have a look at the logs of UPF0. And once we do that, we can see that it has successfully processed the heartbeat request, and these requests are from the SMF, and thus our UPF has established connection with our SMF. And similarly, if we see the logs of UPF1, the same results are seen. Now let us run our RAN and connect the user equipments. So first we will see the logs of AMF, where we have the network slice information available. You can see that over here. And now we also have our radio ready. So we have our radio ready and our command over here. So you see the NG setup response and the green light blinking. And now we can attach the UEs. So here you can see the PDU sessions have been created and the UEs are connected. When we remove them from the airplane mode, we see the 5G symbol, and you can see that everything is working fine and smooth, and they are connected to their respective UPFs. So this basically is a proof of this whole deployment working end to end. And we even have used the commercialized radio over here. So now let's have a look at the scaling part. So for the scaling part, initially you can see we have 0 UPFs available currently. And now we want to scale them up to 2. And you can see now they have started, and the agent is now allocating them. If we watch the status, it will take some time before it actually comes up for us and becomes healthy. Right. So now you can see after some time it's idle and it's up. So we have 2 UPFs ready. And now let's say we need to scale it to 4 UPFs. So I again can enter the command and scale my UPF to 4 units. We can watch the Juju status, and you can see now it's scaling it to 4 units. The 2 new UPFs are in the allocating phase right now. The agent is allocating them. So now we have 4 active UPFs over here, and you can see the status. You can see all of them are healthy and running. And now let's say we need to scale down our UPF. So currently we have 4. We'll scale down all the 4 UPFs towards one single UPF. And when we watch the status, we can see that it has started terminating the other UPFs for us, and only one UPF will now remain. So that was all for this video. Thank you so much.